Hello friends, in today's class we are going to talk about multi-level queue scheduling. Welcome here, and we are talking about multi-level queue scheduling, and this scheduling algorithm is where we are having a different kind of processes, and this different kind of the processes can be what. So welcome here all of you, and we are talking about today the process and okay, sorry. And we are talking about this multi-level queue in this case. Hi Rebel Gaming, how are you? Rebel Gaming, it's a nice name. Hello. Yeah, go ahead if you have any doubt, you can discuss with me. We have another process scheduling concept. Yeah, hello, how are you? Yeah, hi there. Go ahead, what you want to ask. Go ahead, ask your question. Yeah, I'm good also, I'm good. Great, Ganesh, long time. For a long time, I think you have also we have also interacted earlier, I guess, Ganesh, isn't it? Good evening, Ganesh. How are you, Ganesh?
Hello friends, in today's class we are going to talk about multi-level queue scheduling. Welcome here, and we are talking about multi-level queue scheduling, and this scheduling algorithm is where we are having a different kind of processes, and this different kind of the processes can be, for example, there can be a background process and there can be a foreground process. So there can be background and foreground process. There can be interactive processes, like foreground processes are interactive and background processes are something that is required for that computation. Now, another class of scheduling algorithm that has been created for situation where in which processes are easily classified into different groups. For example, common division made between foreground interactive processes or background batch processes. There are two types of the processes have two different response time requirement. So many have different scheduling needs. Like interactive processes response time is high. When you're clicking, let's say, a graphical in GUI, in graphical interface, if you're clicking a symbol, then we need a quick response. Whereas computation may wait. Foreground process may have the priority over the background process, right? So that is also true that we have a higher priority system for foreground process. So now ready queue is partitioned to two separate queues. For example, foreground interactive and background as batch. Processes process permanently in the given queue. Each queue has its own scheduling algorithm. Suppose the foreground process can have a round robin algorithm. Okay, round robin algorithm. And background process may be run in FCFS order. Scheduling can be done between the queues and with the fixed priority scheduling. Serve all the foreground, then from the background, possibility of starvation, time slice, each queue can get a certain amount of the CPU time that it can schedule among the process, 80% foreground in round robin and 20% background in FCFS. Okay, so now we are, you can say that multi-level queue is partitioning the entire, it is not treating each process in the same way. And for each process, according to the requirement, right, according to the requirement, interactiveness and this, we can adopt the scheduling policy, which can be for interactive process, there can be round robin, and for background, it can be FCSE. Scheduling must be done between the different queues. Now we have multi-level queues. So one queue is there, which is having a round, which can be for foreground, and one queue is there for background. And we need different scheduling algorithm. Okay, so we have a fixed priority scheduling where all the foreground and background for priority and possibility of the starvation. In that case, we have that is serve priority wise. If you do, so it will serve everything, and but it may be possible. We have seen that priority based scheduling is having possibility of starvation. And for time slice, if you have then yes, 20% background in FCFS. So that is few ideas about implementation of multi-level queue. So we have a system process highest priority, then interactive process, then lesser priority, interactive editing process, batch processing, student processes, right? So that is a different queues are there. This situation can be a little bit improved by multi-level feedback queue, and the process can move between the various queue, and edging can be implemented in this way. Okay, so multi-level feedback queue scheduler defined by following parameter: that number of queues, scheduling algorithm for each queue, method to determine when to upgrade a process from one queue to another queue, method to determine when to demote a process from one queue to another queue, method to determine which queue a process will enter when the process needs service. Okay, so we have multi-level feedback queue, and that will something look like this. We have three queues over here, that with one is time quantum 8, another is, so that will take out some process with a smaller time quantum, then that will be feedback to this quantum 16, that will take out some process out of here, and then it will be feedback to FCFS mirror, everything will be serviced. Scheduling a new job enter in the queue Q0 and which serves FCFS. When it gains CPU, it receives 8 millisecond. If it do not finish in 8 millisecond, then job is moved to the next queue. At Q1, a job is again served FCFS and receive a 16 millet additional. If it still does not complete, then it preempted and move to the Q2. I think Q0, Q1, Q2, and is three queues are there. And what it is trying to say in this scheduling algorithm is a new job enter into the Q0 with the time quantum 8 millisecond, and we know that that round robin is FCFS, right? When it gained the CPU in FCFS, served FCFS because round robin is implemented through FCFS. When it gains the CPU, job receives 8 millisecond. If does not fill it in 8 millisecond, then it will be feedback to the next queue, that is your Q1. Q1, and at Q1 job is again served FCFS and receives 16 minute additional millisecond, and if it does not complete, then it is preempted and moved to the Q2, and Q2 is what? Q2 is plain FCFS as much as time required. Okay, so that is your example of your multi-level feedback queue. Okay, so that is one good way of so we can have multi-level queues for foreground and background process. This is somewhat a sketch of what can be different queues, and we can have multi-level feedback queue, and that is very simple, that from one queue to another queue with time quantum 8 round robin FCFS, time quantum 16 round robin FCFS, and finally plain FCFS. Okay, so now we are done with this part that is called as multi-level feedback queue. Now what we are going to do here, based on all this theoretical discussion and some calculation, now we are going to solve problem related with this. Okay, so that's all for this discussion. Thank you.
Anyone is here? Yeah, gaming incredible. Tell me what. How you're doing? What you do? Which question? Gaming. Related with what? Related with scheduling algorithm, multi-level queue. OS scheduling, yes, we can solve some question related with this. Uh, you can start with this example with the shortest job first, or you can have FCFS also. First come, first serve that you can try. Like this question in front of you. Do you know FCFS? First come, first serve. Yeah, so go ahead and solve this question. Try to fill this table, like the completion time. FCFS is the one of the simplest algorithm that you are having. So you can prepare the Gantt chart and then you can say that. So the first one is arrive at 0. So now complete the Gantt chart and then we can have the discussion over it, please. So I'm giving you a chance and please complete the Gantt chart and then we can discuss more example. Good. Okay. So with that, I can say here that P1 is here, P1, and P1 will be served. Burst time is arrived at 0, burst time is 4, so up to 4. The second one to arrive is the 2, and it is having burst time of P2, and that will go with up to 9. The third one arrive at 2, and in this case it is coming up, burst time is 6, so P3 will be 15, and then P4. Okay, P4, 15 plus here in this case is 3 will be 18, and then P5, 18 plus 2, this will become 20, and finally 4, and that will become your P6, and that will be 24. Okay, so now this completion time. Completion time is what? Completion time is your so completion time is this times are the completion time, that 4, 9, 15, and then 18, 20, and 24. Turnaround time is different. Turnaround time is when you're submitting the job and it is getting completed. Turnaround time in this case is 4, and here completion time is 9. Okay, turnaround time is completion time minus arrival time. So completion time minus arrival time, this will become 8, this will become 13, and this will become 15, this will become 16, and this will become 19. Okay, now what is the rest of the time? So now if you take out the burst time from this, that is not required to wait. It has to wait for one time unit. It has to wait for turnaround time minus the burst time, 8 minus 5, sorry, this is wrong. 8 minus 5 is this, so 3 time it has to wait. Okay, now why it has to wait? Because it arrived early, P2, and it is completing in 9 time of unit, but burst time is only 5. Okay, so arrived at 8, burst time is only 5, completing at 9. So remaining is your turnaround time is 8. 8 minus 5, 3 time it is waiting. Turnaround time 13. 13 is turnaround, and arrival in this case is arrival time is 2, so that 11 is the total waiting time, and 15 minus 3 is 12, 16 minus 4 is 12, and 19 minus 5 is 14. That is something that is filled the entry in this case. Is it clear? Good. Let me talk some different thing here in this. Let's talk about gate quotient. I think that will give you some sort of challenge. Okay, tell me this quotient. But what about this question, Mr. Gaming? Answer this one. Lowest average turnaround time. Wow. It's a very big question that you have already completed. Very good, actually. Did you compute it now, or you remember the answer? Means you have already done it. So we have already seen good. Your answer is C. In this case, very nice. The question is lengthier, I guess. Huh? C is the option. Okay, you're correct here. Very good.